Hi, this is Chapter 3, Section 2, States and Properties of Matter. We're going to talk very basic ideas about a solid, liquid, and gas. So you've always learned about the properties of a solid, liquid, and gas, and that's further on down in the notes. Right now what we're going to talk about is, at the high school level, what's the difference between a solid, liquid, and gas? What we are looking at is the attractive forces between the particles. So you know that a North Pole magnet and a South Pole magnet have forces of attraction, right? So solids have strong forces of attraction. We'll talk about what those forces of attraction are called later on in the year. Liquids, still strong forces of attraction, not as strong as a solid. Gases, basically no forces of attraction. At the high school level, we basically say gases have no forces of attraction. Not exactly true, but that's what we go with. So, solids have the strongest forces of attraction. That means, let's say ice. Ice is water in the solid form. So a water molecule and another water molecule will have a strong forces of attraction for each other. That's what we're talking about when we say solids have strong forces of attraction. They have very little movement. As a matter of fact, all they basically do is vibrate. And you're often told this in middle school. Think of an atom just vibrating on a spring. It's not a great example, but it's what we typically use. So the atoms that are solid, they vibrate, but they don't really go much more beyond that, right? So they have a very rigid structure, and they have a regular arrangement. Let's talk about what that means. A regular arrangement, think about a typical classroom. You have rows of desks. That's a regular arrangement. Here's what a solid is going to look like on the atomic level. Notice that it has a regular arrangement. Doesn't have to be just dots. We could also have compounds that are a solid. So what we see here, that's an element that's a solid. And what I'm drawing over here, this would be a compound that's a solid. But again, both solids, both have regular arrangement. Okay? So that's also what a solid will look like on the atomic level. Liquids, they also, didn't mean to do that. Work with me here. Please erase. There we go. Liquids also have strong forces of attraction, but not as strong as solids. Again, solids have the strongest forces of attraction than liquids. Since they're not as strong, liquids can move more. So remember the solid, I said the solid is just basically vibrating. Well, the liquid's still strong force of attraction, but now they can move around each other, right? They're still not getting very far away from each other, but they're moving more than the solid, okay? We have what we call irregular arrangement. So let's take a look at what that means for irregular arrangement. Basically, it's not going to be a real pattern. No real, sorry. Just tried to cover up my mistake, it didn't work. No real pattern. All right. So what's that going to look like on the atomic level? So before, remember, a solid, we had this very rigid structure. Now, a liquid on the atomic level is not going to have that rigid structure. It's going to have irregular arrangement. So you see how there's no real pattern here for this, but they're still pretty close to each other. So that's what a liquid's going to look like on the atomic level. Now, the weakest of all the forces is going to be the gases. They have the weakest force of attraction. Now, instead of here's our solid, here's our liquid, here's our gas. Right? They are way far away from each other, never close to each other. Okay? That's going to be a gas. They can move everywhere. Whatever contains them, a gas will spread out and move everywhere in there. Again, we have this irregular arrangement. A gas on the atomic level. So let's go back here real quick. Here's my container. Kind of. Here's my container. Kind of. Now, if this is my gas container, I'm going to have something that looks like this. They are nowhere near each other. Okay? The reason why they're nowhere near each other is because they have weak or basically no forces of attraction for each other. So then this lists some of the typical properties of solids, liquids, and gases that you typically talk about at the middle school level. So here at the high school level, what did we add in? We added in the strength of the force of attraction. Solids have strong forces of attraction, liquids not as strong, gases no forces of attraction. We're talking about between the molecules that make up that solid, liquid, and gas. I'll leave you to read these. For the most part, you've seen these before, and if you have any questions, feel free to ask away. Thanks.